Okay, 4.5, B as in boy, and we just finished up example number 3. So we're ready to go to example 4, and we're going to jump into natural logarithms because they give us an example. E to the 0.08 t equals 2500, and it makes it easier if we're gonna have an e on there. We're going to use a natural logarithm, an ln. Okay, so it just makes it easier if we do that. So let's look and see what we've got here. Can I make this into an e, 2500 into an e? Yeah, probably not. So what I'm going to do is I'm going to take ln e of 0.08 t, and I'm going to make that equal to ln of 2500. All right, one of the things that I know about ln of e is that that's the same as log e 0.08 t. And when we have those two the same, they all go away, and we have 0.08 t left. That was from, I think, the last section. And then that equals ln 2500. Okay. Divide by 0.08. Gets rid of that. And then I can take the natural logarithm of 2500, divide it by 0.08, and I get sorta 97.8, my sorta symbol. That looks kind of like a sorta symbol, doesn't it? Okay, so that means that t is 97.8. So if I take 97.8 times 0.08, I'm going to get a number, and if I take e to that number, that's going to give me 2500. All right, let's jump to example 5. Okay, notice in this one we have more than one term with an x in the exponent. We've got a term here with an x and a term here with an x. All right, so let's simplify it a little bit. So we're going to write it as e to the x plus 1 over e to the x. That negative puts the e to the x in the bottom, and we get that. So I want to get rid of this fraction, so I'm going to multiply the entire thing by my denominator. So when I distribute this times this, I get e to the 2x, right? Because if I take 3 squared times 3 to the 5th, what do I get? I get the base. 2 plus 5 is 7. So that's what I did, is I took the base, and I took x plus x is 2x. So that gave me that. My fraction disappears here because this cancels with this. And then I distribute that e to the x minus 6e to the x equals 0. Now it looks more complicated, but it allowed me to get rid of the fraction. Okay. So let's go ahead and rewrite this with my x's close together. Whoops. Alright, now we can kind of look at this as e squared minus 6e plus 1 equals 0. So what I would suggest doing would be make your e, and this is one thing you don't just naturally think about, let's make that e into a u. Then we don't have to deal with the e to the x anymore. We can just look at it as just an equation. So this is going to be e squared, because e to the, or I'm sorry, what am I thinking? Can't erase anymore. This is going to be u squared, because the e to the x is u, and then squared, minus 6e to the x is u, plus 1 equals 0. Alright, so we go ahead and solve that using the quadratic formula, and we get something crazy like 3 plus or minus 2 square root of 2. Alright, so once we get that, we can replace our u with e to the x. So e to the x then is equal to 3 plus or minus 2 square root of 2. Okay, makes sense? Alright, now that we're in exponential form still, I am going to get rid of some of this stuff here so we can see where we're going. Alright, so this is what we ended with. So if I take ln e to the x equals ln 3 plus or minus 2 square root of 2. So that's what you do when you're in exponential form and you want to continue solving. You take the common or natural logarithm depending on what you're looking at. So remember, when we take the natural logarithm of e, we just get x. And this needs to be in parentheses. Didn't do that. Alright. So this is exactly what the answer is, or you can actually solve it. You're going to get two answers. 3 plus 2 square root of 2, and then take ln of that, and 3 minus 2 square root of 2, and take ln of that. So you'll get two different answers there. And again, what you're getting is where that graph crosses the x-axis. So when you draw this, you're getting this kind of a picture, and it's going to cross here, and it's going to cross here at these 2 points. 3 plus 2 square root of 2, 3 minus 2 square root of 2, and then you take the ln of each of those, and you get two answers there. So, are you seeing that using logarithms allows you to solve problems that look very, very difficult? Because you just take the log of each side. Alright, so now let's look at some logarithmic equations. Let's look at these in logarithmic form. The other ones were just in exponential form. We took the log of each side and we're able to solve. Now we're going to put them in logarithmic form, and we have to get rid of the logs. So we need to do what we can to get rid of the log. So if we have a simple one like this, all we have to do is write it in exponential form, and 1 over 3 squared, or 1 over 9 equals x, and we're done. Alright, so if there is a log on one side, a number on another, then you just change it into exponential form and solve for x. Alright, that's not always going to be the case, but it gives you a direction to go so that you can get rid of the log, because when it's in logarithmic form, that's pretty much your goal, is to get rid of the log. So then that takes us to example 7, and we're going to include a few more logs here. Not make it too impossible, but just a little different. Alright, so let's go ahead and write, I'm not going to rewrite the whole equation, but let's put the base of 10 down here. Might make it helpful just to remember that that's a base 10. Okay, now remember what you do when you have a plus sign. Oops, I'm sorry. What did I do there? I added. I should be multiplying. That's a 3 there, in case it doesn't look like an x plus 3. Okay, so one of our key things is to bring our multiple logs together into one log. Okay, and let's see what we can do from here. Now remember what I said, if we have a log by itself on one side, or we have a log on one side and a number on another, we can write that in exponential form. And that's why I put the 10 there, so we can write 10 to the first equals okay, so 10 to the first power is 10, and that equals x squared plus 3x. And then I write it as x squared. See, I don't have any logs anymore, so I just solve it as a simple algebra problem, and I can factor that into two binomials, x minus 2 x plus 5 equals 0, so x equals 2 and x equals -5. Now the key thing dealing with these is, again, you've got some extraneous roots because you're dealing with your x squared here and logarithms. So you're going to plug in a 2 into the original problem. So we're going to go to our original problem, clear back up here, and we're going to put a 2 in here and a 2 in here. And we're going to find that when we plug 2 in, it works. But when we put 5 in, what did I say, -5? Okay. Find out that that does not work because you can't take the log of -2. So I don't even have to solve this to make sure it doesn't work. I can just see that there's a -2 there next to the log. There's a negative in there next to the log. Isn't going to work. So I have 2 more examples to do, and then we'll be done with this lesson, but I'm going to put it into a next video because it might take longer than 4 minutes.